Okay, so we're going to start our intro to functions. You guys have seen functions before. We just have never really talked about them in terms of a function. You guys have seen the ever familiar x and y table. Okay, so if you had the order pairs of 0, 1, let's make it 2, 2, and 4, 3, and you graphed that 0, 1, 2, 2, and 4, 3, you had what we were going to be calling a linear function. Okay, you guys have seen that before. Now we are stepping it up a little bit and expanding on the idea of the x and y. So now not only is it going to be called an x and y, it may be called input, output. It may be called x and what's called f of x, or read as a function of x. We'll note here, read function of x. You might also see it written as, the independent variable. And the dependent variable. And you might even see it another way of the domain and range. Okay, so those are, besides x and y, which we have seen before, there are 4 other ways of doing the same exact thing, just depending on how you are looking at it. So we have an input-output table, we have an x and an f of x, or a function of x table, independent versus dependent variable table, or a domain and range table. To define a function, it is a relationship that pairs each input value with exactly one output value. Okay, I'm going to build on that idea. When we are graphing, and if we are trying to determine if a graph is a function, there is something called a vertical line test. I'm going to show you how to proceed with that. Okay, so a vertical line test. Excuse me. The vertical line can only pass through the graph at one spot, or in one point. Okay, so I'm going to show you some examples of what are and what are not. So if I have a circle, and I'm wondering if that is a function, if I draw a vertical line through that graph, I'm intersecting the circle in 2 spots. This is not a function. A couple more examples up here. Let's say we have it's called a parabola. And if I draw my vertical line test anywhere, I'm only going to intersect my graph. This line only intersects at one point, this line only intersects at one, and this line only intersects at one. So this is a function. Okay, so if I have a graph of a line, if I use it to check with my vertical line test, no matter where I draw my vertical line, it only intersects at one point, so this is also a function. If I have a graph that looks like that, again, no matter where I draw my vertical line, it's only going to intersect at one point, so this is also a function. And last, let's say we have sideways parabola. I draw my vertical line. It's going to intersect my graph almost every time at 2 points. So this is not a function. So if we look at the ones that we have right now on the graph, if I look at like these points right here, for example. So if I have a table of this, this could be 2, 2, for example, ordered pair of 2, 2. This could be the ordered pair of 4, 4. This could be the ordered pair of maybe 6, 6, etc. Notice for every input, there is exactly one output, one unique output. If I go down to this one, that is not a function, and I do the same X and Y table, maybe this is 2, 2, then this would have to be 2, 8. If I did this one, maybe this is 4, 2, and maybe this is 4, 9, for example. The reason this one is not a function is because your x's duplicate. So if the x's duplicate, or the inputs duplicate, then it is not a function. The outputs can duplicate. And I'm running out of room. Duplicate. Okay? So let's look at this graph right here. I might have this point, maybe it is 6. We'll go at this point. Let's do like 6, 8. And then these 2 points, I would have maybe 4, 6, and maybe this is 8, 6. All of these are unique. These are duplicated, but it's okay because the y's can duplicate. Okay? So if we take this information and just, if I give you a set of ordered pairs, so I'm asking you, is the data in the table represent a function? And I guess does would probably be a better verb. So does the data in the table represent a function? If I give you a table, does this represent a function? Need to pause it, go ahead. The answer is yes. Yes, because no duplicated inputs. Okay, inputs are only used once. Let's try this piece of data. Okay, does that represent a function? And that answer is no. Because we have duplicated input, therefore not a function. So if I give you a graph, your goal should be, if I give you a graph can you determine if it's a function? Or if I give you a table, can you determine if the data represents a function? Okay, so those are our two objectives for this last lesson.